Unit 5 is all about statistics, and Lesson 21 is called Obtaining Data. So before we get started, a couple of things. You can see just from the very beginning of this video that these notes are pretty wordy. So if you are able to print, I would click the printable version link above the video in Canvas and print them out to save yourself some writing. The other thing is that this video has a kind of like set of information that you needed to read through before watching it. It's also above the video in Canvas. So it goes over just like kind of vocab related to conducting a study and different types of studies that we're going to look at. So make sure you read that first before watching this video. Okay, so 21.1 is conducting a study. We're going to analyze a few samples. So situation 1. It says a candidate running for governor of a particular state wants to find out the opinions of the state's residents regarding a certain tax. A survey is conducted to ask the opinions of 500 registered Democrats. So for this situation, we want to decide, is that a good sample? So for the situation, do the 500 Democrats provide good representation of the opinions of all of the state's residents? So if we consider any state, really, are all of the state's residents going to be Democrat, Republican? Are they all going to be a part of one political party? No, it's going to be spread. So this is not a good sample. So we'll say, no, this is not a good representation of the state's residents. It does not collect data from all voters because not everybody is going to just be a Republican or just be a Democrat. Okay, and then situation number 2. A school principal is trying to determine if the student body feels the school's discipline policies are fair. The principal collects opinions through a survey of 10 randomly selected students from each first period class. Every student attends a first period class. So for this situation, does randomly choosing 10 students from every first period class in the school result in a random sample? So think about what types of classes are there going to be during first period. You'll typically see all different types of classes happening during first period. It's not going to be like just only freshmen that attend or just only seniors that attend. You should get a wide spread of all the different types of classes from like math to English to language and including all of the grade levels as well. So as long as they're selecting 10 randomly, I think this is a good sample. So yes, this is a good representation of the student population. The first period classes in the school include all grade levels and subjects, and the 10 students from each class are chosen random. So that's a good way to get, kind of a broad sample, somebody that covers like kind of all the different groups of types of students that you would see within a school. Okay, 21.2 is called correlation versus causation. This one doesn't have a ton of examples. It's really just like going over what these are, what these words mean. So starting from the top, often when a study is conducted, a correlation between the variables can be observed. So this means that when the measurement of one variable changes, the other variable's measure changes as well. So correlation is like they're kind of related, they're related to each other. When one changes, the other changes also. So correlation between two variables is an apparent relationship, but it does not mean that one variable affects the other. So there could be a relationship, but they may not like actually impact each other. They just may be related, may change together. When one variable directly affects another variable, that's called causation. So if something like one variable changes the other, the original variable caused the other variable to change. Okay, so a couple examples of correlation. So this is when they maybe don't actually impact each other, they're just related. So the first one, students who listen to more music earn higher grades. So with this one, maybe they listen to more music because they study more and they listen to music while they're studying, and the studying more results in higher grades. But it's not the music itself that directly causes the higher grades. It may be like the music gets you to study more, but it's the studying that causes the higher grades. So for the music and the grades, we just say those are correlated. And then the second bullet point, food items with higher sodium content have more calories. So that happens a lot, especially you think about fast food, they have pretty high sodium content, but it's not the sodium that causes the food to have high calories because sodium doesn't have any calories. So it's not like, oh, well, the sodium is really high in calories itself, so that's why the food is more. No, it's just correlated. So typically foods that have high sodium are higher in calorie, but it's not the sodium that's causing more calories. And then examples of causation. This is when one variable impacts the other. So first bullet point, the amount you spend on gas is caused by how many gallons you buy. Yeah, like if you buy 10 gallons, you're not going to spend as much money as if you were to buy 15 gallons. So the more gallons you buy, the more money you're spending. The amount of gallons you buy causes how much you spend. And then the second bullet point, the amount of water left in the bathtub is caused by the amount of time the tub has been draining. Yeah, so like the more time that the tub has been draining, the less water it's going to have. So how much time has gone by totally causes how much water is left over. Okay, example 1, determine if correlation, causation, or both exist among the variables. I will say if you have causation, then that's typically going to be a both situation most of the time. So if there's causation, there's typically going to be correlation as well. There can be correlation without causation though. Okay, so in this case, our variables are shoe size and reading ability. So for correlation, think about like if, when we're determining correlation, if it's there or not. So we think about, okay, as shoe size increases, does reading ability typically increase as well? And you think about like with little kids, they're getting older and their shoes are growing and typically their reading ability is developing as well. So we can say, yes, there is definitely a correlation between the two. So yes, they're correlated because as a person gets older, their shoe size increases and their ability to read increases as well. But when we're thinking about causation, like think of it in terms of like, okay, if my feet grow, will my ability to read also improve? Or if I become a better reader, is that going to cause my feet to grow? I think the answer for both those situations is no. So no causation, there should be a comma there. No causation does not exist here. Because an increase in reading ability does not depend on an increase in shoe size. So like if my feet grow, that doesn't necessarily mean I'm becoming a better reader. I have to kind of put in other effort into becoming a better reader. So there's other factors that influence a person's ability to read, such as their education and how much they read on their own. There's other factors as well, but those are just a couple. Okay, so correlation is when they change together. Causation is when one causes the other to change. All right, so 21.3, this one's called displaying data, and we're going to go through like a few different data display types. So the first one is called a histogram, and that shows the frequency of data points within intervals in a visual way. Okay, so for example 1, we're going to create a histogram from this frequency table, and this frequency table shows science test scores. So we're given a few different intervals. Those are just like the different grades received on the test. So like there's like covering the grades 60 to 70, and then the grades 70 to 80, so the C range, 80 to 90, so the B range, and then 90 to 100, so the A range. And then it shows how many different times that data set is occurring. So like this one next to the 60 to 70, that means one person scored in that range. So like one person got somewhere between there. It could be any number though. The 5 next to 70 and 80 means 5 students scored between 70 and 80. The 6 means 6 students scored between 80 and 90, and the 7 means 7 students scored between 90 and 100. In the future, this would probably be like just kind of snagged this problem from a workbook, but in the future, you would hopefully probably see, instead of like the intervals being like 60 to 70 and 70 to 80, you may see like 60 to 69 and then like 70 to 79, so that you're not seeing the same number on each part, just since it's like a test score. So if you get a 70, it kind of puts you in 2 different spots. Okay, so on our like horizontal axis, usually called the x-axis, that's going to be all of our intervals. And notice that like I'm taking the left side of my table and I'm going to put it on the horizontal axis, and then I'm eventually going to put the right side of the table on my vertical axis. So it's just like when we did input and output tables. Okay, so we're gonna kind of create our intervals now. So the smallest number on my table is 60. So I'm gonna put my first tick mark as 60. And a lot of times with statistics, our graph doesn't have to be to scale, so we don't have to go like 1, 2, 3, 4, 5, all the way up to 60 before we put that. We can just put a mark there. We just don't want to put it necessarily at the very beginning because this would technically always be 0. Okay, so 60, and then I'm going to put a 70 there, and then 80, and then 90, and then 100. And then for my frequency, the most that or I guess the highest frequency that occurs of any of the scores is 7. So we at least want to go up to 7 on our vertical axis. I'll probably go up a little bit higher. So let's be 1, 2, 3, 4, 5, 6, 7. I'm just going to do an 8, and I'll go back and label them. And then now we're ready to kind of create our graph, and it's going to look kind of like a bar graph almost. So for a frequency of 1 between the interval of like 60 to 70, we'll do from 60 to 70. So that's this section right here. And then it's going to go up to 1. Like that. And then for 70 to 80, we have a frequency of 5. I'm going to grab a different color just so they don't overlap too much. So for 70 to 80, we have a frequency of 5. So between 70 and 80 is right here. And then we'll go all the way up to 5. I know it's kind of hard when we don't have graph paper. So from 70 to 80, there's 5 students that got within that interval. And then from 80 to 90, there were 6 students. So 80 to 90 is right here. And then we'll go up to 6. And then for 90 to 100, there were 7 students who scored within that interval. So between 90 and 100 right here, we'll go up to 7. Okay, and then you can tell by like the higher the bars are, the more students scored within those intervals. So even if you didn't have like the table to look at, you could be like, okay, well, the most students of any interval scored between 90 and 100. After that, it's between 80 and 90, and then so on down. One thing that's pretty important about histograms is this little section right here. It says, notice that with a histogram, you don't know each individual data value. So what that means is like, I don't know the individual test scores. I only know how many students scored between those intervals. So we don't know the individual data value. Instead, we're given the number of times data occurs within a certain interval. Therefore, we cannot find the mean by looking at the histogram. If you haven't seen the word mean in a while, it means average. So you can never find the average by looking at a histogram because you don't actually know the data values. You just know how many times a certain interval occurs. Okay, moving down to a dot plot. A dot plot includes all values from a data set, so it's already different than a histogram in that the histogram doesn't include the individual values. So a dot plot includes all the values from a data set because there's a dot for each data point. You can use the data points to find the mean and the median of the data set, so it's already a bit different. So example 2, create a dot plot to represent the following situation. So in this situation, we're looking at how many texts somebody sent within an hour. So Joe sent 8 texts within that 1 hour, Sarah sent 10, Megan sent 7, Maria sent 7, Nick sent 10, and Brad sent 10. So for a dot plot, we're only going to have like the horizontal axis, the one that goes side to side, kind of like the x-axis. We won't have a y. And then we don't have to start at 0. We just have to start at the lowest number on our table, which the smallest number, like output number on our table is 7. And there's a couple of them, but we'll just focus on one. So the smallest number on our axis should be 7. And then we're going to go all the way up to the highest value from our table, which is 10. We don't want to skip any numbers though. So we're going to go from 7 to 10. Even though our table doesn't have a 9, we're still going to include a mark there for it. So 7, 8, 9, 10. And then now the way that we take the information from the table and apply it to the dot plot is we just put a dot for each time a number occurs. So like Joe sent 8 texts, so we'll put 1 dot above 8. Sarah sent 10 texts, so we'll put a dot above 10. Megan sent 7 texts, so we'll put a dot above 7. Maria sent 7 texts, so we'll put a second dot above 7. Nick sent 10 texts, so we'll put another dot above 10. And then Brad sent 10 texts as well, so we'll put a third dot above 10. So each value from the table gets its own dot above the number that it represents on your dot plot. And then you could easily take if you didn't have a table, you could take a dot plot and you could figure out, okay, how many of each do I have? You wouldn't have the names of the people necessarily, but you would know that there was 2 people who sent 7 texts, there was 1 person who sent 8 texts, and then there were 3 people who sent 10 texts. So that's why you would be able to find the mean or the median of this data set, because you have the actual individual numbers as opposed to intervals like with the histogram. Okay, moving down to a box plot. Sometimes this is called a box and whisker plot, so those names are interchangeable. So a box plot is a good data display to show the range of data and how it's distributed. In example 3, we're gonna use the following box plot to kind of just figure out where each of the values on a box plot goes. So it says the following box plot shows the distribution of math test scores in one class. Label the individual parts of the box plot. So you may remember these words from, past math classes. If you don't, though, it's not a big deal. You'll use this as kind of your reference moving forward. So there's 5 kind of marks on every single box plot. So the 2 kind of tail ends of the box plot, those are called the minimum and the maximum. So right here, that first kind of dot on the very far left side, that's called a minimum. And that's the lowest value from the data set. And then this last dot over here at the very end, that's called a maximum. And that's the highest value from the entire data set. So minimum, lowest, maximum, highest. And then this line in the middle, that represents the median, which if you forgot the median, so if you take a data set, just a set of numbers, and you reorder them, from smallest to largest, the median is the one in the middle. So you put them in order from smallest to largest, and the middle number is your median. And then box plots have something called a first quartile and a not a second quartile, but a third quartile. So the first quartile is kind of like the median of the first half of the data. So if the median is right here, it starts from the minimum and it goes up to the median. That's the first half. And so this mark right here is the first quartile. So first, and then quartile is Quartile. And the first quartile is kind of I know I already said it, but it's the median of the first half of the data set. It's also kind of 25% of the way between from start to finish, from the beginning of the data set to the end. So if you were to take just the first half of the data set, put it in order. So I'm talking from, in this case, 64 up to 78, put in order from least to greatest, the middle number, and that first half would be the first quartile, and that would be, in this case, 68. Okay, and then the last one that we need to label is called the third quartile. So if we think of from here, from the median to the maximum, that's going to be the second half of the data set, and the third quartile is the median of the second half. So that's going to be this other green line over here. So third quartile. And that means that if I take the second half of the numbers and I put them in order from least to greatest, the one that falls in the middle, that's going to be my third quartile, in this case 86. Okay, and then what box plots do, especially with like the quartiles in there, is they kind of like break the data set into fourths. So I'm going to break this, we'll draw from right here, the minimum, all the way to the maximum. And this would be the first fourth, or the first 25%. So 25% of the class scored between 64 and 68. And then from the first quartile to the median, that would be the second 25% of the class. So 25% of the class scored between 68 and 78. And then from the median to the third quartile, this would be the third 25%. So 25% of the class scored between 78 and 86. And then between the third quartile and the maximum, that would be the last 25% of the class to get the full 100% of the class. So that means that 25% of the class scored between 86 and 96. Okay, moving down to scatter plots. So this is the last one. So a scatter plot is a graph of points plotted on a coordinate plane that visualizes the relationship between two variables. So by viewing a scatter plot, you can analyze the relationship between the two variables by looking for a strong correlation, a weak correlation, or no correlation. So a strong linear correlation is shown as the points are on or near a straight line. So if you see a scatter plot, you see a bunch of different kind of points on a coordinate plane like we have here. If they look like they're almost on a straight line, that's going to be a strong correlation. If they kind of form a line, but they're like pretty loose and spread, that would be like a weak correlation. And then no correlation is when there's no pattern whatsoever. So they're literally just like a bunch of random points. So if we look at our scatter plot here, this one represents like the years of job experience that somebody has and how much salary they make. And you can see these points kind of like all fall close to a line. It doesn't have to be a perfect line, like as if you were like graphing a like regular line. It's just like if they kind of appear to all be close to the same line, like this one does. And I can change the angle of it a little bit if we need to. But this graph would be an example of a strong linear correlation because pretty much all these points are very close to that line that's drawn. So I'm going to add a little note up here that this is a strong linear correlation. And then just kind of think about the context of the problem. So this is showing the relationship between years of job experience and yearly salary. And you would anticipate that the more years you worked, the more salary you would make. So it makes sense for there to be a strong linear correlation.